Elementary Algebra, Assessment 3 Review, questions 9 through 14. In question number 9, the instructions read, rewrite the expression with the positive exponents, then if this expression is numeric, evaluate it. So we have two parts to this problem. First is to rewrite it with the positive exponent, then evaluate it, or solve it. So I have here a 1/2 overall raised to the -4th. Whenever a fraction is present, I can clear the negative sign on the exponent by simply taking the reciprocal of the fraction. So I flip it over. I end up with a 2 over a 1, and now this is a +4. When I look at it, I can now pull the 4 into the parentheses, so I end up with a 4 on the 2 and a 4 on the 1. Well, continuing on, this means 2 times 2 times 2 times 2. Taking the 2, multiplying it by itself 4 times to create a 16. The 1 is multiplying itself 4 times by itself. So 1 times 1 times 1 times 1, which results in a 1. 16 divided by 1 is 16. So I've completed what I'm asked, what's asked of me in the instructions. Let's look at question number 10. The instructions say, write the number in standard form. Number 10 has the electrical resistance of an item being 6.6838 times 10 to the 7th ohms. Because this 7 is a positive value, this means that this is a really large number. So I'm going to copy down the 6.6838, and then I need to move the decimal back towards the right 7 places to bring it back into standard form from scientific notation. So I'm going to come back 7. 1, 2, 3, 4, 5, 6, 7. Put my decimal back in. Then I'm going to record my zeros. A 0, 0, 0. So when I come down here and write the number, I have 66,838,000. Moving on to question number 11, the instructions read, write the number into scientific notation. So what we see here is that on number 11 is that light with a wavelength of 0.00000052 meters is in the green color. We're going to write this into scientific notation. This time it's a really tiny number. So we're going to have to move the decimal to put it into scientific notation. We'll have to move it back until the decimal lands in a point where we have a number that's between 1 and 10, but not equal to 10. So I'm going to move it back 1, 2, 3, 4, 5, 6, 7. So I've gone back to the right 7 places. Put my decimal here. I put it there because it creates a 5.2. That's a number between 1 and 10. So I copy the 5.2 down here, times 10, and this time it was a tiny number, so it's a -7. Going on, question number 12 reads, the instructions read, add and write the resulting polynomial in descending order of degree. So our first step here is to sum the two polynomials together. So I'm going to come in and I'm going to combine the like terms to one another. What I've done first is copied down the first polynomial I was given, -6 plus 9x to the 7th plus 9x to the 9th minus 2x to the 8th. Then I've come over to the second polynomial and I'm going to stack under it all of those terms that are alike. So here I have a positive 9x to the 8th. So that goes under the -2x to the 8th. I have a negative 5x to the 7th, so this stacks under the positive 9x to the 7th. I have a positive 9, bring it over and stack it under the -6. And then lastly, I have a positive 6x to the 9th, so I came over here and I stacked it under the 9x to the 9th. Now I can put my line in here, and I'm going to be summing. So I'm taking a -6 plus a positive 9. They're opposite, so I subtract. I get a 3. The larger value is positive, so the value, or the sign on the 3 remains positive. In the second pair, I have a 9x to the 7th plus a negative 5x to the 7th. Again, they're opposite, so I subtract, and I kept the sign of the larger, which was positive, so positive 4x to the 7th. Moving over, I have a 9x to the 9th plus a 6x to the 9th, so I sum these together and I get a 15x to the 9th. Lastly, I have a negative 2x to the 8th plus a positive 9x to the 8th. This results in a positive 7x to the 8th. Now I'm partway there. The instructions said to add, but it said to add and write the resulting polynomial in descending order of degree. When we're looking at the degree, we're looking at all the variables present, and then we're looking at the exponents that they're raised to summed together. So if I look at this first one, this 3, this has a degree of 0. The second one here on the x is a 7, so it has a degree of 7. The next one over has a degree of 9, and the last one has a degree of 8. So placing them in descending order, I would take the 15x to the 9th first. It has the largest degree, followed by the next largest degree, which in this case is a 7x to the 8th power, and so on. Next would be the one to the degree of 7, so 4x to the 7th, and finally the positive 3, or plus 3. Now it's in descending order of degree. On question number 13, it simply says to subtract. So I had two polynomials here. I had to place the second one on the second line. It became a little bit too long, but I can see that I'm going to subtract these two. So I have two options here. I can keep it as a subtraction problem and work my way down, or I can change this problem to an addition and then just sum down as I did in the second one. If I change this minus sign to a plus, what happens is the sign on each of the terms inside change to the opposite. So this becomes a negative 10b to the 5th, a to the 3rd, plus an a to the 4th, b to the 2nd, minus a 12ab to the 3rd, or I can say plus negative 12ab to the 3rd, plus a 5. So that's what I did in the second line. I simply took the pieces from the second polynomial, stacked them under the first, but I changed the signs all to the opposite. So I have a negative 10 over here now. I have a positive a 4th, b 2nd. I have a negative 12 a b to the 3rd and a positive 5. And I add down. So I add the first two. I have a 4 plus a negative 10, which results in a negative 6. And I copy down the variables, a to the 3rd, b to the 5th. Then I have a negative 8 plus a positive 1, a to the 4th, b to the 2nd. Don't forget there's a 1 in there, even though we don't see it. So that results in a negative 7, a to the 4th, b to the 2nd. Then coming over, I have a 9 plus a negative 12. That results in a negative 3. Carry down the variables a, b to the 3rd. When I get to the negative 8ab, I didn't have an ab in the second polynomial, so there's nothing to sum to it. So I just take the negative 8ab plus 0, which results in negative 8ab. And lastly, I have the 14 plus a 5 to make a 19. Once I've written this out, I should check and make sure that I do have it in descending order, just like the last one. So I see here a 5, 6, 7, 8, so that's an 8, a degree of 8. The second one has a degree of 6. This next one has a degree of 4, then 2, then 0. It is in descending order, so I don't have to take any further action. Moving down, question number 14 says to simplify. What I see over here is that I have parentheses surrounding and I have everything overall raised to the second power. I see the same thing on the second term. So that's what I need to take care of first, are those exponents to the outside. What's going to happen are these exponents are going to come to the inside and multiply to the exponents on the inside. So I'm going to bring this 2 in, and I'm going to bring it in onto that 1/5. So now it's a negative 1/5 raised to the second power. I'm going to bring this 2 in on the x. Even though we don't see it, it has a 1 there. So it becomes a 1 times a 2. The 2 comes in on the 4, so it becomes a 4 times the 2. And the 2 comes in on the 2, so it becomes a 2 times the 2. On the other side, I'm doing the same thing. 2 brought in onto the 1/5, so 1/5 raised to the second power. A 2 multiplied to the 2 on the x, so 2x. A 2 multiplied to the 4 on the y, so I get a 4 times 2. And a 2 multiplied to the 1 on the z, so I get a 1 times 2. Let's go ahead and finish that part of the math. So I have a negative 1/5 times a negative 1/5 to get a 1 over 25. On the x, I have a 1 times 2 to get a 2. On the y, I have a 4 times a 2 to get an 8. And on the z, I have a 2 times a 2 to get a 4. The 1/5 to the second power is 1/5 times 1/5, which creates another positive 1/25. And then on the x's, I have a 2 times a 2 to make an x to the 4th, a 4 times a 2 to make a y to the 8th, and then a 1 times a 2 to make a 2 on the z. Now I'm ready to combine these two monomials. I'm going to multiply the constants first, so the 1/25 times the 1/25, that creates 1 over 625. Then I'm going to combine the variables. When I multiply variables together, if the bases are the same, I just need to sum the exponents. So an x and an x, my exponents are 2 and 4, so I sum them together to make 6. I have a y to the 8th and a y to the 8th, so an 8 plus 8 to make a y to the 16th. And then I have a z to the 4th with a z to the 2nd, so 4 plus 2 to make a z to the 6th power.